So we're looking at a stack of sources today that, on the surface, feel like they shouldn't even belong together.
Right.
On one side, we have these AI field notes from February 2026 talking about how nonprofit admin is being revolutionized by agentic AI.
Mm.
And on the other side, there's this really heavy case study on, well, immunology, rare diseases, and a project called Every Cure.
It does look like a strange pairing at first. I mean, you've got software automating grant proposals on one hand.
And a life or death hunt for a medical cure on the other.
Exactly. But when you actually dig into the methodology, the core logic is it's identical.
It's this idea of utilization versus discovery. I mean, the argument across all these documents is that we've kind of moved past the need to invent more new things.
Yes.
The solutions, whether it's the human capacity to run a nonprofit or, the actual molecule to cure disease, they already exist. They're just hiding in plain sight.
That is the through line. It's a fundamental shift from creation to connection. And the timeline here is specific. The field notes make a really bold claim at the top.
They do.
They say 2024 and 2025, those are the years of the tool. But 2026, this is the year of the agent.
Okay, so let's define that before we go any further, because agent is one of those buzzwords that gets thrown around, a lot.
It is.
The notes make a distinction between this and the chatbots we all got used to a couple years ago. It seems to be about who starts the conversation.
It's all about posture. Think about the AI tools everyone was using back in 2024, like the early versions of ChatGPT or Claude.
Sure.
Those were reactive. You were the driver. You had to log in, type a prompt, wait for an answer. If you walked away, the AI did absolutely nothing. It was just a fancy encyclopedia on a shelf.
Right, it had zero initiative. It just waited to be told what to do.
Precisely. Agentic AI, which is what's scaling up now in 2026, is proactive.
Yeah.
It doesn't wait. It has a goal, it monitors its environment, and it acts.
So the analogy in the notes is the difference between an intern you have to micromanage
And an executive assistant who knows your schedule better than you do. Yes.
The donor engagement example really stood out to me. In the old tool era, I'd have to remember I hadn't spoken to a major donor in months. Find their email, and then ask the AI to draft something.
Whereas in the agent era, the software is just watching your CRM database 24/7. It notices the 3-month gap. It sees the donor just posted about something on LinkedIn.
And it drafts the email for you.
It drafts the email and pings you and says, hey, I've prepared this note for donor X based on these parameters. Want to send it?
That shift from create this to review this feels fundamental.
Oh, it is.
And that Gartner statistic in here is pretty aggressive.
It's huge.
They're predicting that by the end of this year, 2026, 40% of enterprise apps will have these agents embedded. That's a massive jump from, single digits just 2 years ago?
It's moving incredibly fast because the infrastructure is finally there. And for nonprofits specifically, it's critical. We're not talking about huge tech companies with unlimited R&D budgets.
No, we're talking about organizations that are almost always understaffed.
Always.
So let's look at the practical applications here. The notes list a few areas. Grant discovery seems to be the big one.
Grant discovery is, it's the bane of existence for most development directors.
Yeah.
Historically, it's just this manual slog of scouring databases, checking criteria, and usually missing deadlines because you're swamped.
So the agent approach changes the physics of that. You have a system that's just constantly scanning thousands of sources.
But it's not just keyword matching, which has been around for a while. This is semantic matching. The agent understands the nonprofit's mission, its nuances, it tracks deadlines, and, crucially, it filters out the noise. It only alerts the human when there's a really high probability match.
So it's like having a researcher who works 247 and never sleeps.
Exactly, or gets bored.
The reading also mentions Salesforce Agent Force. This feels a little more complex than finding a grant application. It's moving into donor prospecting.
It is. It's about analyzing behavior. The agent looks at a database for wealth capacity, sure, but it also looks for signals of readiness.
The next best action.
Right. It might tell a fundraiser, based on how this person interacted with your last newsletter, you need to call them today, not next week. It optimizes the human's time.
But I have to play devil's advocate. We're talking about giving software agency to act. The notes mention consistent execution, which sounds great, but what happens when the execution is consistently wrong?
That is the risk. That is the entire ballgame.
I mean, if you have an agent that hallucinates, which they still do, and sends a personalized email to a major donor that gets their name wrong, or, God forbid, references a spouse who's passed away.
It's a disaster. You've damaged years of trust in an instant. Or in operations, an agent misinterprets a vendor code on an invoice, and suddenly your finances are a mess.
Which is why the implementation checklist in these sources is so focused on guardrails.
You cannot just turn these things on and walk away. You have to set up what they call confidence thresholds.
Okay, confidence thresholds. Explain how that works in practice.
It's basically a logic gate. You program the agent with a rule. If you are 99% confident this invoice matches this purchase order, go ahead, process it. But if you are only 80% confident, maybe the date format is weird or something, do not act. Escalate it to a human for review.
So the human's job shifts from doing the work to managing the exceptions.
Exactly. It's the human-in-the-loop concept. The goal isn't to remove people, it's to elevate them. And the notes use a great phrase for this. Redesign, don't automate.
Right. If you have a broken process and you just add AI, you get a faster broken process.
You're just scaling the chaos. You really are. You have to step back and ask, if we had unlimited capacity, how would we do this perfectly? Design that workflow first, then put the agents in.
There's a really interesting example of this with the crisis lines. I mean, that's high stakes. You don't want a chatbot handling a suicide intervention poorly.
That is the nightmare scenario. But the hybrid model described here is smart. The AI handles the initial triage. It sorts the incoming messages. But the millisecond it detects high-risk language or sentiment, it immediately escalates to a human professional.
So it lets the humans focus 100% of their energy on the cases that need real empathy and judgment.
Instead of sorting through intake forms.
Yeah.
Exactly.
This connects right back to that theme of utilization. The AI clears the clutter so the human can do the human thing. And I think that's our bridge to the second half of this deep dive.
It really is.
Because if you look at the methodology, scanning a massive data set to find a hidden match that a human missed, that is literally the definition of the medical breakthrough we're about to talk about.
It's the exact same algorithmic approach, just applied to biology instead of, philanthropy.
Huh.
We're pivoting from agentic AI in the office to computational pharmacophonomics in the lab.
Okay, so let's talk about David Fajgenbaum. His story anchors this whole part of the discussion, and I think we need to slow down and really appreciate the gravity of where he started. Because before any of this, he was a patient who was completely out of options.
He really was. Go back to 2010. David's a third-year medical student at Penn. He's a former Division IX quarterback, a weightlifter. He is the physical embodiment of health.
And then just abruptly, his body crashes. It wasn't a slow decline, it was a cliff.
A complete system failure.
Yeah.
Liver, kidneys, heart, lungs, bone marrow. He's in the ICU, his organs are shutting down one by one, and the doctors are just baffled.
They eventually diagnose him with something called Castleman disease.
Which is this rare condition where the immune system just goes rogue and attacks the body.
The notes mention he had his last rites read to him. Not once, 5 times.
Can you just imagine that? You're in a hospital bed, your family's there, a priest is there, and the best doctors in the world are telling you, we have nothing left to try. Desperation is just hard to comprehend.
And the drugs they were using were chemotherapy, right?
Yeah, but they were just blasting a system blindly, trying to nuke the immune system to stop the attack. But it was always a temporary fix. He'd get better for a few weeks, and then it would all come roaring back.
And he knew the next relapse would probably be the last one.
That's right.
This is where the story pivots from a tragedy into, well, a thriller. David decides if the doctors don't have the answer, he has to find it himself.
He turns himself into an experiment of one, a sample of one. He starts analyzing his own blood samples from the different flares of the disease, looking for a pattern.
And this is the key. He wasn't trying to invent a new molecule. He was looking at the data to see if there was a signal that everyone else had missed.
And he found one. He found a specific protein pathway, it's called the mTOR pathway, that was spiking right before his immune system would crash. It was like a check engine light that was flashing. But no one was looking at that part of the dashboard.
So he identifies the target, but knowing the target is one thing, you need a weapon to hit it with.
Well, this is the utilization moment. He remembered from medical school that there was a drug called sirolimus. It was an immunosuppressant used for kidney transplants.
So not a Castleman's drug at all?
Not at all.
Yeah.
But, and this is the whole point, its mechanism of action was inhibiting that exact mTOR pathway.
So the drug was just sitting on the pharmacy shelf the whole time?
For 25 years. It was FDA-approved decades before. It was cheap, available, safe. But no one had ever connected the dots between sirolimus and Castleman disease.
So he makes the connection. He tries it on himself.
A massive gamble. And it worked. He's been in remission for over 11 years now. He saved his own life by repurposing a tool that already existed.
And that brings us to every cure, because David realized his story wasn't just a miracle, it was a proof of concept. There must be thousands of other Davids out there.
Right, and this is where we get into the systemic market failure of the pharmaceutical industry. To understand why every cure needs to exist, you just have to look at the math. There are roughly 18,500 recognized human diseases.
Okay, 18,500.
Only 4,000 of them have an FDA-approved treatment.
Wait, so that leaves 14,500 diseases with no designated cure at all.
It's a staggering gap. And the reason is pure economics. Developing a new drug from scratch costs, what, $1 to $2 billion and takes 10 to 15 years?
And a pharma company can't spend $2 billion on a rare disease that only affects a few thousand people. The ROI just isn't there.
It's not. So the notes introduce this term, computational pharmacophenomics. This is the AI engine behind every cure.
So how does it actually work? Because AI finds a cure sounds a bit like magic.
It's not magic, it's a knowledge graph on steroids. Every cure built a system that ingests the world's biomedical knowledge. We're talking PubMed abstracts, clinical trial data, molecular structures, millions of documents.
And it's looking for, what, hidden relationships?
Exactly. A human researcher might specialize in kidney transplants, another one in immunology. They don't read each other's papers. The AI reads all the papers.
So it might notice, hey, this protein in this kidney paper is structurally similar to the protein causing this rare blood disorder.
Precisely.
Yeah.
It creates a giant matrix. On one axis, you have all 3,000 existing FDA-approved drugs. On the other, all 18,500 human diseases. And the AI calculates a match score for every single intersection, millions of combinations.
The notes mention the speed of this. It used to take 100 days to run these calculations.
And now it takes 17 hours. Every 17 hours, they can re-rank the entire universe of drug-disease relationships based on new data. It's incredible.
And this isn't just theoretical. We have actual case studies here. The story of Joseph Coates really struck me.
Joseph is a powerful example because his condition was so similar to David's, but his biology was different. He also had Castleman's, but the drug that saved David sirolimus, it didn't work for him.
And he was failing fast, being trapped for hospice.
He was. And in this moment of just, pure serendipity, on David Fajgenbaum's birthday, the Every Cure algorithm flagged a totally different drug as a high probability match for Joseph's specific profile.
And they got the drug to him.
They did. He walked out of the hospital. He's been in remission for 2 years.
There's another example in here that I think will resonate with a lot of people, and it's about autism.
This one is fascinating.
Right.
The AI identified a drug called leucovorin, which is basically a form of vitamin B. It's been around forever. And the algorithm predicted it could help a specific subset of children with autism who have a certain metabolic issue.
And the result was speech.
For some of these nonverbal children, yes. The notes describe parents hearing their child say, "I love you" for the first time. Again, not a new billion-dollar invention. It was a vitamin derivative hiding in plain sight.
It really validates the kind of funding they're getting. I mean, $110 million is not small change.
No, and having ARPH, the government's high-risk health agency backing them, validates the science. They realize the market is never going to solve this. If you can cure a disease with a generic drug that costs pennies, no company will fund the trial. A nonprofit has to step in.
So if we pull back and look at the whole picture today, we have AI agents in nonprofits scanning databases to unlock human capacity, and we have AI agents in medicine scanning molecular databases to unlock cures.
It's a unified theory of smarter utilization.
Right.
In both cases, the limiting factor wasn't the resources. The resources were already there.
The limiting factor was our ability to see the connections. We were drowning in data, but starving for insight.
That's it exactly. And the role of AI here isn't to be the creator, it's to be the ultimate librarian. The thing that says, hey, you already have the answer. It's on shelf 4, row B.
Which leaves us with a pretty big question for you, the listener, to chew on. The notes from the field end with this provocation about time and attention.
And I think this is the most important part. If these agents work, if the admin work drops by 20 hours a week, if drug discovery time drops from years to days, the question is, what do we do with the surplus?
It's so tempting to just say, great, let's just do more work.
Right, the efficiency trap. Let's send more emails, process more invoices. But the author suggests something else. If the machine handles the processing, the human obligation is to handle the meaning.
Listen more closely. Imagine more boldly.
Exactly. If you're not buried in spreadsheets, you can actually sit with a donor and hear their story. If you aren't spending 10 years in a phase 1 trial, You can spend that time understanding the patient experience,
The technology buys us the space to be more human again.
if we choose to use it that way. And that is the big if.
Well, that is certainly something to mull over. Whether you're running a nonprofit or just trying to manage your own inbox, the tools are changing, but that mission to connect remains the same.
Couldn't have said it better myself.
Thanks for breaking this all down with us today.
Always a pleasure.
And thank you for listening. We'll see you on the next Deep Dive.